Okay, I'm Manish Madala. We'll be doing chapter 4, problem number 46. So there's 3 blocks touching each other on a frictionless surface, and there is a force applied to block 1. So then now we have to draw the free body diagrams for each of the blocks. So then the free body diagram for block 1 will be force gravity, force normal, the force applied, and then a contact force from block 1 and block 1 touching block 2. And then the free body diagram for block 2 will be force gravity, force normal, the Newton's second law of force contact 1 on 2, and there's another force contact because block 2 and block 3 are in contact also. FC 2, 3. And then the free body diagram for the third block will be force gravity, force normal, and then force contact 2 on 3. So then that's it for part A. Now part B is asking for the acceleration of the system in terms of mass 1, mass 2, and mass 3. So then for part B, we're doing the whole system. So then a sigma F statement for the whole system would be mass 1 plus mass 2 plus mass 3 times acceleration equals force applied. So then the acceleration will equal force applied over mass 1 plus mass 2 plus mass 3. And that's the answer for part B. Okay, and then part C is asking for the net force on each block. So this part is simple. So then for block 1, sigma F1, the net force is mass times mass of block 1 times acceleration. And then sigma F block 2 would be mass times acceleration of block 2. Then the net force of block 3 would be mass of block 3 times acceleration. And that's for part C. And then part D is asking for the contact force each block exerts on its neighbor. So then for this, we have to solve for 2 separate contact forces because there's a contact of block 1 and block 2, and the contact of block 2 and block 3. So first for the contact on block 1 and block 2, sigma F equals mass times acceleration equals force applied minus FC 1 on 2, and then force contact 1 on 2 equals force applied minus mass block 1 times acceleration. So that's how you solve for force contact 1 on 2. And then there's also the sigma F for force contact 2 on 3. To solve for that, use mass 2 times acceleration equals force contact 1 on 2 minus force contact 2 on 3. Force contact 2 on 3 would equal force contact 1 on 2 minus mass 2 times acceleration. And that is how you solve for force contact 2 on 3. So part E states that all 3 of the masses are equal to 12 kilograms, and the force applied is 96 newtons. So they want numerical answers for parts A, B, and C. So then the numerical answer for part B, since we got acceleration would equal force applied over mass 1 plus mass 2 plus mass 3 would equal 96 over 12 plus 12 plus 12. And this simplifies to 96 newtons and kg. and this would simplify to 8 over 3 meters per second squared. So then, and then the numerical answer for part C would be sigma F1, and then would be 12 times 8/3 equals 32 newtons, and then it's the same for block 2 and block 3 because it has the same mass and same acceleration. And block 3, same mass, same acceleration. And then the solutions for part D. So force contact 1 on 2 would be force applied minus, so it would be 96 minus mass 1, so 12 times 8/3 newtons, 12 kg per second square. So that would equal 96 newtons minus 32 newtons, which gives us 64 newtons for force contact 1 on 2. And then to solve for force contact 2 on 3, it's force contact 1 on 2, so 64 newtons minus mass 2, 12 times acceleration 8/3, and that equals 64 newtons minus 32 newtons, which will give us 32 newtons for force contact 2 on 3. So these are all the answers. Part A is all the force diagrams. Part B is solving for the acceleration. Part C is net force on each of the parts. Part D is solving for the force contacts. Part E is getting numerical answers for all 4 parts, and numerical answer for B is 8/3 meters per second squared. Numerical answer for C is 32 newtons for all 3 of the blocks, and the numerical answer for part D is 64 newtons force contact 1 on 2 and 32 newtons force contact 2 on 3.